What's up, everybody? This is your boy Tech G back with another video to help you successfully pass the CompTIA Network Plus N10-007 certification. So let's get into it. In this video, you're going to learn about various fiber optic transceivers and various cabling termination points. Let's talk about a transceiver. So a transceiver, this is an electronic device which is a combination of a transmitter and a receiver, hence the name. It can both transmit and receive digital signals for communication purposes. These two related functions are often combined in a single device to reduce manufacturing costs. Let's talk about a fiber transceiver. So a fiber transceiver, this is a single package device that uses fiber optic technology to transmit and receive data. The fiber optic transceiver comprises of both a transmitter and a receiver, which are combined and share circuitry or a single housing. It is an important part of an optical network equipment that has electronic components to condition and encode and decode data into light pulses and then sends them to the other end as electrical signals. And the first type we have is called bidirectional or BIDI, and this usually consists of two different wavelengths to achieve transmission in both directions on just one fiber, whether it's single mode or multi-mode. In a bidirectional transceiver, it enables the signal to be sent and received in both directions by different center wavelengths. And then the next one we have is duplex. A duplex fiber cable consists of two strands of glass or plastic fiber, typically found in a zip core construction format. This cable is most often used for complex communication between devices where separate transmit and receive are required. Next, we have an SFP or a small form factor pluggable. The SFP, this is a compact, hot pluggable network interface module used for both telecommunication and data communication applications. An SFP interface on networking hardware. This is a modular slot for a media-specific transceiver in order to connect a fiber optic cable or sometimes a copper cable. The advantage of using SFPs compared to fixed interfaces such as modular connectors and Ethernet switches is that the individual ports can be equipped with any suitable type of transceiver as needed. Next, we have a GBIC or gigabit interface converter. A GBIC, this is a standard hot swappable electrical interface, single gigabit port that can support a wide range of physical media from copper to long wave single mode optical fiber at lengths of hundreds of kilometers. Then we have SFP Plus or enhanced small form factor pluggable. The SFP Plus takes the benefit of the SFP design and improves on their data capacity. SFP Plus still functions with copper and optical cabling, but it can achieve much higher speeds. Data rates at 10 gigabits per second, and on the newer fiber channel design, SFP connections can hit speeds up to 32 gigabits per second. Then we have the QSFP or the quad small form factor pluggable, and this is another expansion of the original SFP concept. The QSFP uses double fiber pairs. The QSFP allows for substantially more powerful data transmissions, and the QSFP connector, they are still small and hot pluggable, and they still support Ethernet and fiber optics. All right, let's talk about termination points. And the first one we're going to talk about is the 66 block. So a 66 block, this is a type of punch down block used to connect sets of wires in a telephone system. They have been manufactured in three sizes. You have A, B, and M. A and B have 6 clips in each row, while M only has 4. The A blocks have the rows spaced further apart and have been obsolete for many years. The B style is used mainly in distribution panels where several destinations need to connect to the same source, and the M blocks are often used to connect a single instrument to such a distribution block. Next, we have the 110 block. So a 110 block, this is a type of punch down block used to terminate runs on premises wiring in a structured cabling system. The designation 110 is also used to describe a type of insulation displacement contact connector used to terminate twisted pair cables, which use a punch down tool similar to the type used for the older 66 block. Then we have a patch panel, and this is the device or unit featuring a number of jacks, usually of the same or similar type, for the use of connecting and routing circuits for monitoring, interconnecting, and testing circuits in a convenient, flexible manner. Patch panels are typically built into a wiring closet or added to equipment racks, and patch panels are primarily designed as a termination point for twisted pair and fiber cables used in networks. And then we have a fiber distribution panel. So a fiber distribution panel, also known as a fiber optic patch panel. This is mainly used for accommodating fiber cable terminations, connections, and patching. With fiber optic distribution panels, network technicians can control massive fiber cables and connection points in a standard panel or enclosure structure. Therefore, fiber distribution panels make it simple and convenient for us to do cable management and maintenance. All right, so this was my quick little video. So in summary, we have talked about various fiber optic transceivers and various cabling termination points. Now, if you felt like you've gotten something valuable out of this information, go ahead and hit the like button, share button, drop a comment, but most importantly, subscribe to this channel. Also, go check out my website, Technology G, so that you can get read up on the latest and greatest to help you successfully pass the CompTIA Network Plus N10-007 certification. And until next video, ladies and gentlemen, peace.